Hey there, welcome to The Explainer. I want you to imagine, just for a second, that you've just walked into the engineering headquarters of a massive Fortune 500 company. I'm your senior tech lead, and today is your onboarding for a multi-million-dollar project. So, let's just dive right into this. We aren't just cobbling together some quick weekend project here. No way. We are architecting a fully production-grade, multi-agent, generative AI platform right from the ground up. This system we're building is designed to ingest massive amounts of corporate knowledge, autonomously orchestrate really complex workflows, and operate with the absolute strictest security and observability that the enterprise level demands. So grab a coffee and get comfortable, because by the end of this explainer, you are going to have the exact blueprint for how elite engineering teams are building the autonomous systems of the future. Okay, here's our ultimate architectural blueprint. We're going to start with the enterprise AI vision, then lay down the foundation and RAG pipeline, move right into multi-agent orchestration, lock down our memory and AI safety, cover observability and cloud deployment, and finally, we'll talk about what this means for your engineering career impact.
All right, Section 1, the Enterprise AI Vision. Like I said, we are moving way beyond basic chatbots here to build a system that solves real, complex corporate problems and does it autonomously.
You know, an enterprise platform really has to justify its existence, right? It needs to prove its worth. And this system provides immediate return on investment in three massive ways. First up, as an internal knowledge assistant. Imagine an AI that has basically memorized every single standard operating procedure, every API document, and every HR policy across literally thousands of PDFs. It's just sitting there, ready to answer any employee question instantly. Second is AI workflow automation. We aren't just talking to the AI anymore. The AI is actually doing the work. It can autonomously create Jira tickets, query enterprise databases for metrics, send update emails, the whole shebang. And third, we have the enterprise support agent. This is all about automating those tedious IT and HR workflows. When a system can natively execute these tasks without waiting for a human bottleneck, the ROI is absolutely staggering.
Now, to build that kind of vision, you need some serious tools. For the back end, we're relying heavily on Python and Fast API with ASIC.io. We absolutely need that asynchronous programming because, let's face it, AI API calls take time, and we can't have our entire system blocking while we wait for a language model to respond. For our AI frameworks, we're leveraging LangChain for the orchestration side of things and AWS Bedrock to actually manage our language models. To store our AI's knowledge, we need vector databases. Think Qdrant or ChromaDB. And then for traditional data and deployment, we're relying on the rock-solid trio of Postgres for relational data, Redis for our caching, and Docker for containerizing the entire microservices architecture.
Moving right along to Section 2, Foundation and RAG Pipeline. Because before our AI can actually do anything, it needs knowledge. Retrieval Augmented Generation, or RAG, is the absolute bedrock of our platform.
To actually get all these documents into the AI's brain, we first have to process them. The very first concept you've got to understand here is chunking. Imagine trying to read a 500-page corporate manual in one single breath. You can't do it. Well, neither can an LLM. It has a limited context window. So chunking is simply the process of splitting those massive documents and giant PDFs into smaller, logically digestible pieces of text. It's basically like turning a massive textbook into a neat stack of highly focused flashcards.
Okay, so once we have our flashcards, the machine actually needs to understand what they mean, and it does that through embeddings. We convert those chunks of text into mathematical vectors. You can think of embeddings as the secret language of the database. It maps concepts spatially. So if two chunks of text mean the exact same thing, even if they use completely different words to say it, their mathematical vectors are going to sit really close together in the database. This is what allows for incredibly powerful semantic search.
So let's look at how this all flows together sequentially in our pipeline. Step 1, PDF ingestion. We just feed the raw corporate documents directly into the system. Step 2, we apply chunking to break them down, and we generate those embeddings for every single chunk. Step 3, we index all those vectors into our vector database, like Qdrant. And finally, Step 4, when a user actually asks a question, we perform a semantic or hybrid search to find the exact chunks of knowledge required. By doing it this way, we are essentially giving the AI an open book test. Instead of forcing it to just guess the answer from its pre-training, it retrieves the exact company document. This drastically, and I mean drastically, reduces hallucinations.
Section 3, Multi-Agent Orchestration. This is where things get really fun. This is where we transition from an AI that just reads stuff to a whole team of AIs that actually does the work.
I want you to stop thinking of your code as just a bunch of scripts and start thinking of them as highly specialized digital employees working together in a highly coordinated firm.
We've got a planner agent whose sole responsibility is task decomposition, breaking huge problems into smaller, manageable steps. A research agent focused entirely on retrieving knowledge from our RAG pipeline. A database agent that is actually authorized to execute SQL queries. An API agent that reaches out and talks to external services. A summary agent to perfectly condense information. And crucially, a security agent to strictly validate prompts, plus an evaluation agent to QA the final output. They all have their own distinct, specialized responsibilities.
Let's ground all this complex architecture in a very practical, everyday enterprise scenario. Imagine an executive logs into the platform on a Tuesday morning and types this exact prompt: generate monthly sales report and email management. Now, in a traditional basic chatbot, it would just spit back, "I'm sorry, I don't have access to your sales data or your email." But let's see what happens in our multi-agent system.
The user hits enter. Boom. Step 1. The planner agent grabs the prompt and decomposes it. It instantly realizes, okay, this requires data retrieval, summarization, and an external action. Step 2. The database agent jumps in and executes a SQL query to pull this month's exact revenue numbers. Step 3. The summary agent takes that raw data and drafts a polished, professional report. Step 4. The email agent accesses the company's mail API and fires the report off to management. And finally, Step 5, the evaluation agent logs and validates the final output for QA. Flawless execution. Not a single line of human intervention required. That right there is the power of true multi-agent orchestration.
All right, Section 4, Memory and AI Safety. Because listen, a brilliant AI is utterly useless to an enterprise if it forgets instructions 5 minutes later or acts recklessly with private company data.
Let's talk about memory first. For an AI to actually feel intelligent and conversational, it needs context. We implement this in two distinct ways. First, we have short-term memory. We handle this by using caching tools like Redis. It stores the recent conversation context and ensures session persistence, which basically just keeps the current chat feeling fluid and natural. But then we have long-term and semantic memory. This is stored securely in our Postgres and vector databases. This acts as the AI's permanent corporate experience. It stores historical conversations and vector embeddings, so the AI actually learns over time and personalizes its responses based on all its past interactions.
Now think about this. If our AI can remember everything, and it has the actual tools to query our secure financial databases and send emails on our behalf, we have to ask a frankly terrifying but absolutely crucial question. How do we actually protect an autonomous system that has access to our company databases and email servers? Because a rogue agent or a cleverly disguised malicious user prompt could be absolutely disastrous.
Enter Phase 6 of our architecture: guardrails. These enterprise armor components are 100% non-negotiable for production. We implement prompt injection detection to prevent malicious users from trying to trick the AI into executing unauthorized commands, like, trying to drop a database table. We use toxicity filtering to immediately block harmful content. We have incredibly strict PII detection, that's personally identifiable information, to automatically hide or mask sensitive data like social security numbers or private client details long before it ever even hits the LLM. And finally, output moderation completely validates the AI's responses before they are ever sent back to the user. Validating both the input for injections and the output for sensitive data is quite literally the only way you're going to sleep soundly when you have autonomous agents running in a production environment.
Section 5. Observability and Cloud Deployment. Once the system is built, we have to be able to deploy it efficiently and strictly monitor its every digital thought.
The old saying is true: you can't improve what you don't measure. By using tools like Langsmith for LLM tracing and Grafana for our dashboards, we track some specific, highly critical metrics. Latency for one, because enterprise users absolutely will not sit there and wait 45 seconds for a response. Token usage, measuring both prompt and completion tokens, because every single token costs the company real money. Hallucination rate, which tracks incorrect outputs to ensure our RAG pipeline is actually doing its job. And the tool's success rate, to actively monitor how often our agents successfully execute their tasks versus just crashing. Tracking token usage and hallucination rates are absolutely the keys to running a cost-effective, reliable platform.
When it comes to actually deploying this beast, we follow a very strict maturity timeline. Phase 1 is entirely local development. We run everything locally in Docker, using Ollama for local free language models and a local instance of Kudrant. Phase 2 is moving to staging on the cloud. Here we spin up AWS EC2 instances and start using managed services for PostgreSQL and Redis to really test our network latency. Finally, phase 3 is production. We deploy our entire microservices architecture on Kubernetes for autoscaling. And crucially, this is where we switch our LLM provider to AWS Bedrock. Abstracting the LLM provider through a managed enterprise service like Bedrock allows for seamless scalability, incredible security, and it gives us the ability to easily swap between top-tier models like Claude or Llama as the market inevitably evolves.
And finally, Section 6, your engineering career impact. Because understanding this blueprint isn't just some fun academic exercise, it is a massive, massive lever for your own personal career growth.
I want you to literally imagine having this exact bullet point on your resume. Built a production-grade generative AI platform using FastAPI, LangChain, RAG, vector databases, and multi-agent orchestration. Pitching that exact line to a hiring manager instantly validates that you have mastered the complete lifecycle. It completely elevates you far, far above the massive crowd of developers out there who are really just writing basic API wrappers. You are demonstrating true enterprise-level back-end engineering excellence, perfectly combined with cutting-edge AI orchestration. And having that exact specialized knowledge unlocks the absolute top-tier engineering roles in today's tech market. We are talking about highly specialized, highly compensated titles here: AI agent engineer, generative AI engineer, AI back-end engineer, or specialized LLM and RAG engineer roles. The market right now is absolutely desperate for builders who actually understand memory management, guardrails, observability, and complex tool calling systems. They don't just want people who know how to type a prompt into ChatGPT.
So we've laid out the entire enterprise architecture for you today, from the solid foundation of the RAG pipeline to the incredibly complex coordination of specialized agents, securely locked down with guardrails, and flawlessly deployed on the cloud. The blueprint is officially yours. So the only thing left to ask is this: are you ready to move beyond basic chatbots and actually build the autonomous enterprise systems of the future? The tools are out there, the architecture is totally proven, and the next step is entirely up to you. Get out there and start building.